This is a second video for integrated 3. Now, I've noticed that yesterday there was a ton of questions from the worksheet. I have answers for like problems 11, 12, 13. I know those were ones that a lot of y'all were having trouble with. If you want to see the answers to those and how like all the step-by-step, send me a text or an email and I'm happy just to forward that over to you. I might also tomorrow go ahead and post that on Google Classroom so y'all can take a look at that. That said, I was looking through the worksheet that y'all are going to have today, and I noticed that it was pretty much the same stuff as the video. I think there might not be too much problems with that. If you do, always text me and email me. But 11 and 12 were a little bit different from the notes, so I wanted to go over those. All right, so here's what we've got. Now, it's like it describes this region rather than giving to you like an axis and actually showing you like the square or the triangle. It wants you to create the shape yourself. So think about, like, I've got an x-axis, I've got a y-axis, right? We'll call that my x-axis and that my y-axis. And then we've got this line here, right? We've got y equals negative x plus 4. Well, you remember graphing your lines, right? We're up 4, there's your y-intercept, and then negative x. So it's got a slope of negative 1. So that means we're going to be coming down something like that, all right? And when we say the region that is enclosed by those equations, what we're talking about is we're inside all 3 of these boundaries. So we're really looking at is this triangle right here. And it's rotated around the given axis. So it is being rotated around the y-axis. So we're going to take this and we're going to spin it around vertically. All right, so we're going to spin it around the y-axis. Well, if you think about what happens if I take that triangular shape and then I just spin it around the y-axis, what it's going to make is it's going to make this some sort of a cone. You can think about the mirror image being on the left side, and then that rotation, it's going to give us like this cone here, right? Because that height is going to be 4. And if you want to do like the over 1, down 1, over 1, down 1 with the slope, what you would notice is that this radius from our center out to this edge, this radius is also going to be 4. Because that point on the x-axis, our x-intercept would be, I just wrote that wrong. It would be 4, 0. But we don't care too much about the point. The point's really just to tell us what the radius is, right? Because it wants us to sketch and describe the solid that is produced. So what we would say is we've got this cone here, right? Looking at that yellow cone. We've got a radius of 4, and then the height is also 4. Right? When I say the height, I'm talking about this height from the bottom up to the top right here. Right? So that height is going to be 4, and then also our radius is 4. And then it wants us to find the volume of the solid. All right, so you want to remember that formula for volume of a cone. We've got volume equals pi times the radius squared times the height. And then we divide that whole thing by 3. All right, so go ahead, plug those values in. You're going to get pi times 4 squared, right? The radius is 4. The height is also 4. Divide that whole thing by 3, and let's see what that comes out to. It's going to give you an answer about volume is 67.02. And we can just say units, right? Because it doesn't give us any actual measurements. We can say units cubed. All right, one more down here. So we got x equals 6, y equals 0, and y equals 2x. And it's rotating around the x-axis. All right. So let's see what we've got. You know what? I'm going to make a new page for this because the way this is, I've got like no room down at the bottom. So we're going to try this over here. All right. Let's see. Let's bring this over here. There we go. Now I've got a little more room. All right, let's make our x and y axes. We got a y-axis. We got an x-axis. There's your y. There's your x. So we've got this vertical line right here, x equals 6. We can draw that guy over here. There's my line, x equals 6. And then we've got the line y equals 0. So that's just the y-axis, right? Or I mean, sorry, the x-axis. That would be this line right here, y equals 0. And this guy's my x equals 6. And then we've also got the line y equals 2x. So that's going to be this line right here. It's got a slope of 2. Y equals 2x. And if we look at the area that's enclosed, right, enclosed by all three of these, we're going to be looking at this triangle, right? We've got that y equals 2x, x equals 6, and then y equals 0. Those are like our three boundaries of that triangle. So we're looking at this region inside here. And then we're going to want to rotate that around the x-axis this time. We're going to rotate it around the x-axis. So that's going to be taking the triangle and then rotating it like upside down. We're rotating it this way. It's not going to be vertical like the last one. It's going to be horizontal. All right, so think about if I rotate that horizontal, it's going to create a mirror image down below. And the rotation would look something, would be going this direction. So we have, again, we're going to have something looking like another cone. All right, and what we need to do is we need to figure out what is the height, what is the radius. All right, so if we want to describe it, we can say we've got a cone, and we want to know what the height, and we want to know what the radius. All right, so our height, that is going to be from the center up to the top of the cone. Well, this would be from 0 on the x-axis over to this over here would be 6. So that height, that distance from here to here, that distance is going to be 6, right? Because we're going from x equals 0 over to x equals 6. And then for our radius, I'll do that in green. We're worried about this distance right here. So we're wondering, well, that black line, x equals 6, is intersecting that red line, y equals 2x. Right, so I want to figure out that intersection. I want to figure out what that height is. I want to figure out this point right here. Well, the way we figure out where two lines are intersecting is I could just plug in 6 into this equation, right? That's going to give me that intersection. That gives us y equals 12. So that gives us the radius. So that radius is going to be 12. Right, that's the height of that green line. All right, so now I've got a height of the height of the cone, and I also have a radius of the cone. All right, so that's going to be the cross section, and again, you're going to use that same formula. We've got volume equals pi times the radius squared times the height divided by 3. And then we're going to put the radius in there, so we got pi times 12 squared. We're going to put the height in, that's a 6 over 3. And then once again, that's going to go straight into the calculator. Let's see what that gives us. And that's going to give you an answer of 904.78 units cubed. All right, as always, if you have any questions, let me know. I just noticed that those problems were a little different from the notes, so I wanted to give you a chance to see those worked out. All right, let me know if you have any questions.